So today I'm going to talk about token maxing, which is this stupid new idea that programmers should max out the number of tokens they use every day, or if not max them out, at least use as many as they possibly can, and that any programmer who doesn't max out their token usage isn't being as productive as they should be. Along the way, I'm going to spend some time talking about how we've measured productivity for programmers over the years, and how we really ought to measure it, and why no one really ever does it that way. And I'll give my guesses as to why people are suggesting token maxing, and why I think it's been catching on, aside, of course, from the fact that so many people are doing it just because they're gullible as This is the Internet of Bugs. My name is Carl. I've been a software professional since the late 1980s, and I'm trying to do my part to make the internet a safer, less buggy place. I've been on YouTube for a couple of years now, and I do other things on the internet which you can keep track of on internetofbugs.com if you're so inclined. I'm not going to dig too deep into where the idea of token maxing came from here, because there are plenty of places you can learn that. I'll stick some links in the description if you care, and because I find that just thinking about how we got here to be infuriating. But here are some early examples of kind of how we got here. Jensen Huang from Nvidia, who makes more money on AI than any other company, was on the All In podcast on March 19th, saying that he would be alarmed if an engineer wasn't using enough tokens. And then March 20th, an article from the New York Times popularized the idea of maxing out token budgets. And then on March 23rd, the most prestigious venture capital firm, who was heavily invested in the AI bubble, published a letter, quote, to software CEOs, founders, boards, and the investor community, unquote, called, quote, "There are only two paths left for software," unquote, in which they push the idea of an AI-driven developer productivity. That letter is going to do a monumental amount of damage, and I'm working on a video about that, which I hope will be ready soon. So subscribe if you want to see that. And if you want to hear about it even faster, it came up on my last Friday Patreon Q&A Zoom call. So you can join the Patreon link below and ask about it or anything else you might want on this week's Q&A call. Some companies are even putting up leaderboards to show which programmers are burning through the most tokens. Now, I have no hesitation in saying that's an incredibly counterproductive way to incentivize for real productivity. It's just yet another and arguably the worst attempt to turn programmers into micromanaged laborers with no agency or opportunities for creativity I've seen in 30-something years. So let me start talking about measuring programmer productivity by saying something that should not be controversial at all. Not all code is good code. In fact, some code is bad code. In addition, with the exception of code that's so bad it should never be used under any circumstances. All code quality is situational. Code can only be good if it does what needs to be done in the situation in which the code is called. So that begs the question, how do you know in what situations any particular block of code might be called and what it should do in each of those? That's not an easy question to answer. And I'd argue that the majority of hard-to-find bugs are caused when a block of code is called in a situation that the programmer didn't anticipate. And that's one of the most crucial and most difficult parts of writing code, anticipating all the different conditions under which the code being written might be called, what the right thing to do is in each of those situations in coordination with all the things being done in that situation by all the other code around the code currently being written, and then doing all of that while keeping in mind that there are people out there, often referred to as hackers, who will intentionally try to force your code to encounter malicious situations so they can try to take financial advantage of what it does wrong. Under no circumstances does writing more code faster make that process any easier or better. In fact, quite the opposite. Unfortunately, doing that correctly is hard to effectively measure, and under certain constraints, it's impossible to even attempt to measure it, but we'll talk about that more later in the video. But the paper pushers want to measure something, and so they look around for things to measure. Counting the lines of code a person or team writes in a certain period of time is a very easy thing to measure, so people often use it as a metric. But it's a horrific measure of productivity, because to do that correctly, lines of good code should add to your score, but lines of bad code should be deducted from your score. But there's no easy way to tell what lines of code are which. Now, test coverage, lines of code that are covered by automated tests, is a better metric, but it only helps if the tests are correct, thorough, and accurately emulate all the situations under which the code that will be called in the real world. And in the 25 plus years since I first started writing automated tests with JUnit, I've seen lots and lots and lots of bugs that happen in production because the test didn't anticipate reality. Another attempt at metrics are story points or t-shirt sizes or planning poker or whatever crap method you use to try to estimate the size of a piece of functionality. I've never seen that be a good approximation, but at least it attempts to measure code in the context of an expected piece of functionality, so I'll give it credit for trying. It does, I guess, approximate productivity better than just counting lines of code. But token maxing, it's literally the worst metric for measuring good programming I've ever heard of, or at least the worst one that wasn't stated sarcastically or intended to be a joke. Because token maxing is roughly equivalent to trying to maximize the lines of code if every single line of code was billed to the company directly in addition to any other costs. Goodhart's law tells us that when people start being judged based on a metric, it ceases to be a good metric because people will gain the system. But with this nightmare, the more people gain the system, the more companies who are pushing the metrics have to pay their AI vendor, which I guess is great revenue if you're the AI vendor, but not so great for everyone else's finances though. So why are companies doing this? So some of the earliest companies who are reported to be doing this, like Meta and Shopify and Amazon, are probably pushing this metric for purposes of training their in-house AIs. Like I've talked about many times on this channel, most of the data that is available to train AIs has already been used to train AIs, and getting new high-quality data suitable for training is very difficult. In theory, if you could take the output of your AI and then track how that output gets refined and changed as it gets used in the real world, and then add that tracking and change information back into the model, that could become good training data, which could maybe lead to an AI that might be better at generating better code. Now, there's a bet there. Those companies are betting that the pain caused by the bugs that your current customers are feeling now because of the slop that your current AI is pushing to your production environment will be smaller than the gain that you get later from having better trained models in the future. I'll be honest, it sounds like a bad bet to me, but time will tell. Now, some other companies aren't training their own AIs, and they're doing it because they aspirationally mimic everything that they read about the big companies doing without having a clue as to whether the reasons the big companies are doing it apply to the littler companies or not. Now, that's stupid, but that's the way of the industry. I've talked before about how the whole LeetCode interview culture came from idiots copycatting the big companies that had specific reasons for interviewing developers that way. Agile was a process designed to make it easier to do software consulting, but many companies adopted many of the Agile practices internally without understanding what they were actually for. Pull requests were designed to be a barrier interface between groups maintaining open source code and external developers who wanted to contribute features and bug fixes. But they've become the standard way of developing inside a company development team now for no good reason. Software engineering is still a young industry, and it's still largely driven by superstition, trial, and error. Yet other companies are pursuing token maxing because the people in charge there believe that AI, as it exists right now, would be a huge productivity multiplier if their stupid employees would only use it. This is because a combination of wishful thinking, irresponsible reporting by the media and influencers, and propaganda put out by people who stand to gain financially from people who are using more AI. See Jensen Huang mentioned earlier. And token maxing is going to cause a lot of problems. Probably already is. There might be some small chance it turns out to be worth it for the companies developing their own internal models at some distant point in the future, although I doubt it. But there's no doubt it's going to cause more problems before there's any chance of things getting any better. Now, some of us have seen this kind of thing before at companies where programmers were judged based on how many lines of code they wrote. That leads to a lot of really, really bad code being pushed into production. And what was really fun was when idiots just wrote a bunch of code they never actually ran and stuck it in the code base without ever calling it just to get credit for the lines, which often leads to some other idiot assuming that that code, since it's in production, works and either copies it and pastes it into somewhere else or calls into it expecting it to do what it says it's going to do. So quick word of advice, don't ever ship dead code. It causes way more problems than it seems like it should. And yes, that means don't ever ship code that's locked behind a feature flag. The largest amount of real money ever lost to a bug, $440 million, was because of code hidden behind a feature flag that was not supposed to be run, but there was a bug in the way the feature flag was implemented. And I'll put a link down below. It's the 2012 Knight Capital Group meltdown. If you're curious about it, it's a really interesting story. Now, in full disclosure, there have been some bugs since then that theoretically lost amounts of cryptocurrency that might have totaled more than that, but I'm talking about the biggest actualized loss here. Okay, so I've said a lot about how you should not measure programmer productivity. So what does work? The answer is to allocate time on every code change, especially bug fixes, to be spent looking back at the code that was changed and deducting the value of the current bug fix from the metric score for the original code, which also means deducting it from the person that wrote the original code. Now, people hate this. First off, management hates it because it means that everything takes more time. Programmers hate it because it means more paperwork time and less programming time, and programmers pretty much always hate that. But it also breaks fundamental business accounting and evaluation practices. If you want to run your company such that you can evaluate at the end of a time period, like quarter or week or month or whatever, what was done in that period for purposes of allocating bonuses or raises or whatever, then you can't allow looking back to previous time periods and revising what the past productivity measurements were, which prevents you from measuring productivity effectively under those kinds of circumstances, even if you really wanted to. But those exceeding rare people that do manage to do this looking back exercise, even if they only do it for particularly bad or harmful bug fixes, and take the additional time to really understand how the decisions that were made in writing of the original code led to the bugs that you found recently, those people learn incredibly valuable skills that, in my experience, just can't be taught or learned any other way. And those skills certainly can't be learned by token maxing. And the AI has no chance of learning from any kind of such exercise. Personally, I expect the token maxing fever will die off. I've already started to see reports of companies complaining about how expensive it is. The question is, will the fever die down before or after the AI companies use the revenue they get from it to prop up their IPO paperwork? These upcoming IPOs, starting with the Frankenstein X.AI and SpaceX conglomeration in a few weeks, are going to be a Groundhog Day event for the AI bubble. Now, that's the rodent forecast superstition thing, not the time loop thing. If the IPO sees enough money, then we're going to get at least 6 more months of bubble. And the market is trying to do their best to make that happen. And token maxing is only one part of that. There are others, including the financial irregularities going on between Anthropic and XAI, the way that NASDAQ is changing its rules right in time for the series of IPOs. But yeah, that deserves its own video. So subscribe if you want to see that, or if you want to talk about it sooner, you can join my Patreon and we can talk about it in the Q&A session. But whether you do those things or not, please at least remember that the internet is full of too many bugs already, and anyone who says different might well be trying to sell you their new IPO. Thanks for watching. Let's be careful out there.